I'd like you to start class today by proving this identity in your notes. Press pause on the video, and when you're ready to see the answer, press play again. So here's how I chose to prove it. I proved it on the right side. I rewrote cosine 2 theta as 1 minus 2 sine squared theta. And then I simplified. I distributed the -1. And when I did that, the 1's went away, and I had 2 sine squared theta in my numerator. In the denominator, I wrote sine 2 theta is 2 sine theta cosine theta. And when that happened, I was able to cancel the 2's and cancel one of the sine of thetas. It ended up being sine of theta over cosine of theta. And that, of course, is tangent of theta. So I've proven my identity. Today we are going to talk about half-angle identities. Press pause on your video and write these identities down. When you're ready, press play again. So there is another half-angle identity besides one of the three that you've written for tangent of x over 2. It's a half-angle identity for tangent. This is connected to our warm-up. In our warm-up, we proved this identity. Tangent of theta is equal to 1 minus cosine 2 theta over sine 2 theta. Do you see the connection? Theta here is half of 2 theta. So that is the proof of the half-angle identity for tangent. So add this to your half-angle identities. You now will have 4 of them. Press pause when you're ready to proceed. Press play again. And here's another half-angle identity. Again, write this one down. When you're ready to move on, press play again. Okay, so the first application that we're going to use with these half-angle identities is that I'd like to find an exact value for cosine of 165 degrees using the half-angle identity. Now, cosine of 165, we don't know directly because it's not one of the standard angles on our unit circle, but 165 times 2 is 330, and that is an angle that we know an exact value for. So I am going to write cosine of 165 as cosine of 330 over 2 and use my half-angle identity. Remember, the half-angle identity is cosine of theta over 2 is plus or minus the square root of 1 plus cosine of theta over 2. So in this case, theta is 330 degrees. So we will rewrite that using our identity, plus or minus the square root of 1 plus cosine of 330 degrees over 2. Now, the plus or minus part we determine based upon the quadrant of the angle I'm trying to find. So since 165 degrees is in the second quadrant, and I know cosine is negative in the second quadrant, I know then that this must be negative. So it's negative the square root of 1 plus cosine of 330. Cosine of 330 is square root of 3 over 2. And then that's over 2. And now what's left is for me to simplify. That's negative, let's see here. The numerator would be 2 over 2 plus square root of 3 over 2. So that's 2 plus square root of 3 over 2 all over 2. That will cancel, and I end up with negative square root of 2 plus the square root of 3. And while that may look ugly, that is the exact answer. Now, I would like to use some half-angle identities to find sine of x over 2. I'm given that cosine of x is 3/5. Well, okay, and it's in quadrant 4. I know that sine of x over 2, that's my dog, just ignore her. Sine of x over 2 is plus or minus the square root of 1 minus cosine of x all over 2. Now, the plus or minus part. X, I know, is in the fourth quadrant. That means that x is between 3 pi over 2 and 2 pi. If I divide all of this by 2, I know that x over 2 must be between pi, that's 2 pi over 2, and 3 pi over 4. That I got by taking 3 pi over 2 and dividing by 2. So this x over 2 has to be in quadrant 2. Now sine in quadrant 2 is positive, so that my answer will be positive here. And I already know cosine of x, so I'll plug in. That's the square root of 1 minus 3/5 all over 2. And again, that's positive because x over 2 is in the second quadrant. So that becomes 5 over 5 minus 3 over 5 is 2 over 5. So the square root of 2 over 5 all over 2. That is, these twos go. So it would be 1 over the square root of 5, and then I would rationalize. So it's the square root of 5 over 5. Now, if I was given sine of x instead, I would have had to draw a triangle where x was in the fourth quadrant and find cosine because my identity involves cosine of x. Now, I would like you to proceed and find cosine of x over 2 and tangent of x over 2. Press pause on your video when you're ready to see the answer. Press play again. Okay, so here are my answers. I used the identity for cosine of x over 2. The only difference with the half-angle identity for cosine and sine is that it's 1 plus cosine in the numerator rather than 1 minus. So again, I substituted in and I simplified, and I knew that it had to be negative because, of course, x over 2 is in quadrant 2 and cosine is negative in quadrant 2. So this became negative 2 square root of 5 over 5. When I went to find tangent of x over 2, I simply used the identity tangent of x over 2 is equal to sine of x over 2 over cosine of x over 2. So I used the quotient identity to find tangent of x over 2. Okay, I'd like you to try this. Press pause on your video. When you're ready to see the answer, press play again. Okay, so cosine of x over 2 ends up being negative 2 square root of 13 over 13. I was given cosine of x is negative 5 over 13. I was told that sine was negative, so I knew cosine was negative, and sine was also negative, which would mean that it had to be in the third quadrant. I found that x over 2 then must be between 90 and 135, which means it's in quadrant 2. Therefore, cosine of x over 2 is less than 0. So when I used my half-angle identity for cosine, I used the negative value. So I plugged in and I simplified, and voila, there's the answer. Now, I'd like to use my half-angle identity to find an exact answer for tangent of 15. Actually, I'm going to have you do this. And I want you to use this identity. Tangent of a over 2 equals 1 minus cosine of a over sine of a. Press pause on your video. When you're ready to see the answer, press play again. So I noticed 15 degrees is half of 30. So I used tangent of 30 over 2 equals 1 minus cosine of 30 over sine of 30. And I knew that cosine of 30 was square root of 3 over 2. And sine of 30 was a half. And then I simplified. The next thing I'd like to do is prove this half angle well, it's an identity involving a half angle. It's really tempting to start on the right side. Let's see, I'm just going to write up top what cosine of x over 2 is so I know what we're aiming to find. So this is 1 plus cosine of x over 2. Now the nice thing is when it gets squared, the square root sign will go away. So what I really need to do is I need to work on this right side and change everything to be in terms of sines and cosines and hope that everything cancels so I just get a cosine of x left. So let's give this a try. I'm going to work on the right side. Tangent I will change to sine of x over cosine of x. Sine of x stays as it is, all over 2. Tangent I'm going to write as sine of x over cosine of x. Now, in my numerator, I'm going to get a common denominator. That common denominator is cosine of x. So that will become sine of x plus sine of x cosine of x. That's all over cosine of x. That is over 2 sine of x over cosine of x. This will cancel. And in my numerator, I will have sine of x cancel out. Well, not cancel, factor out. Sine of x factors out, and that will be 1 plus cosine of x, and then that's over 2 sine of x. Ooh, getting very close here. Notice we are trying to get to this. I see the 1 plus cosine of x over 2, and I can rewrite that as the square root and then square it so it looks exactly like how I want it to be. And I'm running out of room here, so I'm going to just wind around. I'll start here. That will be plus or minus the square root of 1 plus cosine of x over 2, and that is squared. And then that is cosine squared of x over 2. Done. Okay. Now I'd like you to work on the assignment that's posted online. Have a great day.